Hello everyone, welcome to a new episode from Golang Cafe, and today we're going to talk about the context package. Today's episode is going to be about how to use the context package, which you can find in Go in the standard library, and what is it about, what is it used for, and we're just going to go through a very simple example on how you can use it. So the first thing I would like to do is to go through the docs of the context package itself. You can do that by just typing go doc using the go doc command line utility, and you can see that it's a very small interface. So what it is all about is that it's a very small interface, and the first thing you should do is instead of going to the actual interface, you can actually just go to the package level. So it just gives you a little bit of overview of what is it about and what is it used for. So it's a type, obviously, and it's usually for deadlines and cancellation signals. So you can generalize it as a tool for propagating cancellation signals across API boundaries, so across different parts of your application. It is also used for storing some type of values, which is request scope data that transit processes and APIs. And it's not used for passing optional parameters or functions. So you can summarize it in two major functionalities. The first one is for cancellation signals, so propagating signals across different part of your application. That's one scope, one objective. And the second objective, which is a bit rarely used actually, so you don't actually use it a lot because it's a very loose way of passing data around. You can store data within the context itself. You can think of it as a map or as a arbitrary container where you can actually see here. We can highlight. That you can pass data using a key value and an empty interface. But today we're going to focus on the actual context for cancellation signals and deadline propagation. So we're going to see a little example. Our example is a program that is a search engine for flights. So let's get it started. So the first thing I do here is define what we're gonna build. So it's a search. Is a little program. That searches flight routes. So it's like a search engine for flights, basically, right? But it's we're gonna use a mock, and we are going to use a mock backend database. So it's not a real search. It's just to show the purpose of this is to show how the context can be used to propagate cancellation signals across different Go routines, really, and processes, if you will. So processes intended more as a way of abstract processes. Like if you have different layers in your application and you define those as a processes, but it's more like passing different cancellation signals between Go routines. So let's get started with the example. So the example is pretty basic. We have a function that does a search, and obviously what it does is using from and to, and is returning a list of routes and an error. And let's say that for the sake of testing, we're just using a predefined list of results, right? So we have our mocked function here. So what it does, it just basically takes from and then to, and then it says the airline. So British Airways, 11 a.m. and then there's from, and then to, and then you have Delta Airlines at 12 a.m. So this is the mocked results that we want to return. Let's just say, for the sake of argument, that this is a very slow function. Search is a very slow function. It's a very slow function that goes through a series of operations and return a slice of strings. And the internal of this function is implementation detail. Okay, let's say that this function takes between one latency between 10 and 5,000 milliseconds. Okay, so this is what the search function takes. So the search function takes between, now we need to sleep for a random period between 10 and 5,000 milliseconds, okay? And then we see it with time Unix.now. I think it was something like that. Then we create, so we see it, and then we create the interval. Max latency minus latency plus 1 mean latency, and this is latency. And then what we do, we just sleep time duration for latency, and then we specify that this is milliseconds. All right, that should make sense, I think. Let's see if we've done it all right. So we have the math run, and then we need a bunch of other things here. We need to import the time package. We need to import the math random package, and we will need as well, I think that's it for now. So this is our search function. It takes very long time. We're just having creating a pseudo real scenario where the search function takes between 10 milliseconds and 5 seconds. Let's see if this goes, if it compiles. So this is print starting to search for MSC to London, and then you do search MSC and London, and then you have your results. Got results. Okay. The second. Here we need the font. We need to check for the actual error. Let's say that now it doesn't return any error, and let's try it out. Okay, it works. So I just wanted to check. We want to actually show what's the latency. Started to search for from 2 takes. So it's from to latency. This is going to be an integer. We remove this stuff here up. So now should so we just need to change this. So in this case, it's taking 1.8 seconds. So we run it again, it's going to take almost 5 seconds, and so on. You got the gist. So once we know that we have this this function here, we want to be able to set a timeout. So the objective is we want to be able to set a timeout such that we don't want the user to wait more than 3 seconds while we do the search. So if the operation takes more than 3 seconds, then what we do, we abort the search and we return. And that's where the context comes in handy for us. So the context is really useful for, as I said, signal propagation. And what you usually do in this case, you always pass the context inside the function that you want to control, in this case where you want to control the propagation of your signal. But let's start first from the main, and the first thing that you do is create a new context. New context, and you can do new context like that, cancel context with timeout, context background, and then you have to specify the timeout. Okay, so let's say that we specify the timeout here. Timeout is 3 seconds. Okay, now let's go back here. Time dot duration timeout, time dot millisecond. So let's go through it first. So the first thing we've done, we've created the context background. So it's a background context, isn't the full context. So let's just go through it. Context of background. Context background returns a not-nil empty context. It is never cancelled, has no values, and has no deadlines. It is typically used by the main function, initialization, and tests as the top-level context for incoming requests. So you have to think of the context as an hierarchical structure, like if it is a tree. And that's how the context works. So you always have a root context, and from the root context you can then derive children from this root context. So the first thing that you do when you create your functions, when you create your methods, and ideally when you create your first your main function, you create the root context. And how do you create a root context? Well, the root context is usually the context background, because it never gets cancelled. So this is the root context, and you can do something like that. So context.background. Let's just comment this for a second. So this is the root context. The root context never gets cancelled, so that's important to remember. There is never an occasion where the root context gets cancelled, unless the root context is then fed into the context with timeout. So let's say that from the root context, then we want to create a new context, and this new context has associated a timeout with it. So what we do, we just create a new context with timeout, and we use the root context as a parent. And we can easily see that through the context with timeout signature, where you can see the first thing you do, create the background context, which is a context that never cancelled, an empty context, the root one. And then when you want to specify context with a timeout, what you do, you just create a context with timeout, and you pass a parent context. And the parent context usually is this background context, but it can be any other context. It doesn't really need to be the background context. In this case, we just have one, so we just use the background context. We use the root context, we call it in this case, as a parent. And then we specify the timeout. We say, okay, after how much time this context needs to expire. And there is also an interesting thing here, which is the cancel function. The cancel function is used to release all the resources associated with the function and with the context, and it's used after at the end of the operation. So you always need to call the cancel function so that it releases all the resources associated with the context and with the parent context eventually. So we have the root context, we have the context with timeout. So let's just go here in line 24, context with timeout, we can call it. We have the cancel function, which needs to be called. We usually call it as with a defer, which is called at the end of the program is called so that all the resources are released. And bear in mind that whenever you call the cancel function, the context is cancelled. So if we were to remove this function, if we were to remove the defer keyword here, what would happen is that the context with timeout would be cancelled immediately after we call the cancel function, but we don't want that. So we just call it at the end of the function, the main function. So with the context with timeout now, we just need to pass it to the search function, and somehow we need to work out a way to return earlier than when we would return if we didn't have the actual context. So the objective here is after 3 seconds, instead of waiting 5 seconds, you want to wait at most 3 seconds. If it takes 10 milliseconds, it's fine. If it takes less than 3 seconds, it's fine. If it takes 3 or more seconds, then what happens is that the search is cancelled and then we return without any results. And how we do that? Well, let's say that we encapsulate the function. So let's say this is a very slow function. So slow search. Let's say this is a DB lookup, it's an API call, or any other thing. Is any other thing really? It's something that you want to. It's something that it's very slow, and you want to control the timeout over that. Okay. And the first thing, so here, this is an implementation detail we have here. So we just have the slow search, and we rewrite the search function, but this time we have the context. So we know that this context will tell us whenever we need to exit this function, whenever we need to close this function, return early. So we just have the signature as always. We have our return type. We have all the stuff that we've done as well before. But the only thing is that now we have the slow search that we need to watch from another coroutine, and then concurrently we need to check if the slow search is taking more time than the context, is slower than the context, when the context is cancelled, basically, when the context is expired, basically. How do we do that? Well, there is a way to check when the context is cancelled, and you can do that by looking at the context.context, and then you go to done. So done returns a channel that's closed when work done on behalf of this context should be cancelled. So it's basically closed. This channel is closed whenever whenever there is a cancellation signal. Whenever the context is closed, the context is cancelled basically. So whenever the timeout arrives to the end, the done channel is closed, and so we can use this then. We can use this in a select to understand when the context is closed. And here it says with cancel arranges for done to be closed when cancel is called. With deadline arranges for done to be closed when the deadline expires, and with timeout arranges for done to be closed when the timeout elapses. So it depends on which type of context you have. So as you see, we have different types of context. We have cancel with deadline with timeout. We're using with the timeout one. So whenever the timeout elapses, the done channel is closed, and that's when we know that the timeout has expired. So we can reflect that in our function. We can say, okay, now in line 34, what we need to do, we need to watch for context.done. So watch for when context.done is closed. So when context.done is closed, it means that we reached our timeout. And how do we do that? So the first thing we do is we watch our slow search function. We let our slow search function go, and we collect the result in a channel. In this case, this is implementation detail of this specific example, but you could have also other simpler examples, for example. So slow search, which is using from and to, and then once this slow search is done, which is using, which is getting the results. Okay, this one returns, I think it returns an error as well. Let's say that these returns are, let's just ignore the error for now. Let's for this example, let's just say that it doesn't return any error. So it becomes much simpler. So we have our slow search. The slow search returns is very slow, and once it's done, it returns the value into the rest channel, which is an unbuffered channel. Then we close the channel, so we don't need to send any other data in. And then what we need to do, we basically here we spawn a coroutine that is doing heavy lifting for us. Is waiting for the slow search to go. And at the same time, what we do, we have a for loop. So we wait, we go here on loop, and we wait for two events. We wait for two events here. So wait for two events, either of one. Either of one will be the result of the operation. And the first one is very simple. The first one entails the actual destination result that is coming from the channel, and this means that if we receive this first, there is no error, and the slow search has taken less than the timeout. And then there is another case, which is context.done is close. And in this case, we return context.error. So we return the reason why the context has been closed, which in this case is the timeout has elapsed. So we just return this, and we need to add the signature here as well. Here we miss. Okay. So what we've done, we just collected, we created a routine. We're waiting for the result to come over, which is a very slow search. And at the same time, we basically spawned the routine, and immediately at the same time, what we've done, we're going through a loop for waiting, and we are constantly waiting for two events. One of the two events. The first that we just here we wrote here is the result from the slow search. And the second is the timeout, is whether the timeout has elapsed or not. So this one will go on loop, and whichever of those two events will return first, then what we get as a result, it will be the actual either the destinations or it will be the error. And the error will represent basically in this case specifically, we represent whether the search has been too slow for us. And then we can easily see by just looking at the error here. So we just print ln the error, got error, and then we return. If we try to run this, let's see. Obviously we need to import the context. Let's see what other thing we need. The context, we need to pass the context, and the most important thing is that we have defined the context in the search function. Now we need to pass the context in the search function. And which context we pass? We pass the context with the timeout, obviously. Context with timeout. So now it's taking less than 3 seconds. It will complete successfully. Let's just put some formatting here. just to get it a little bit more let's see now what okay, now it should time out. And as you see, we got error, context let line exceeded. Let's try again. Let's see the random. Okay, now we go with alpha second. It's returning all right. Now it's 4 seconds. It should return the error as well. As you can see now, we are timing out whenever the operation takes more than 3 seconds, and that's what we wanted to achieve. And that's what the actual context with timeout allows us to do. It allows us to create a context that carries a cancellation signal, which is attached to this time.duration that we specified at the beginning. Let's see what happens if we pass the root context in. We shouldn't have any cancellation if we pass the root context, because the root context doesn't have any kind of deadline attached to it. As you can see now, it's 2 seconds. Okay, 2.5. Let's see if there is an example that comes up as more than 3 seconds. Here you can see 4 seconds. Now it shouldn't time out. As you see, it doesn't time out because it uses the root context. It doesn't have any cancellation signal attached to it. So let's put back the context with timeout. And I just wanted to go through one last thing, which is timeout. So we have now we have one cancellation signal. So if you look at a high level perspective, we have very slow operation, one cancellation signal, timeout based. And we can also do another thing. We can also have another cancellation signal, which is based on a cancel func base. It is based on another operation that we will see, cancel func based. So let's say that we want to gracefully shut down the server. Okay, and we don't want to leak resources. Let's say that whenever we run this function here, this and we send the signal interrupt, we want to intercept this signal, and we want to stop the search. So how do we do that? So we do it by basically calling the cancel. We call this cancel function here before, not before, but in the same moment we receive the interrupt signal. So how do we do that? We need to set up the interrupt, listen for interrupt signal, and this is usually done with a channel that contains a signal, I think, and then is syscall notify should notify the channel of let's see the documentation, codoc syscall.notify signal notify channel, and then you have a list of signals. Okay. So this is signal notify OS interrupt, and then it was syscall sig term, and then we create a coroutine and we listen if we have received this signal. And whenever we receive the signal, it means that we need to cancel now cancel. We just call the cancel func. That easy. And here we just say print ln, and we say aborting due to interrupt. We call the cancel func, and we exit. I think that's it. Obviously, we need to import all the things. That's how it is. So whenever we then send an interruption signal, the context gets cancelled. Let's see. Yeah. So it's basically that simple. So whenever whenever the signals, whenever we receive the cancellation signal, then we cancel the context, and it's that simple to use the context to propagate signals. So we have the cancellation based on the timeout, and we have the cancellation based on the cancel func, which you can trigger yourself. In this case, we just trigger it based on the interrupt signal of the operating system, and you could trigger it by different types of scenarios. So it doesn't necessarily needs to be from the interrupt signal. You could have a different routine, you could have a different operation running, and that operation cancel the context, and that context automatically will cancel as well. So it is pretty much what's left. In this case, we are not seeing the got error function here print, because what we do, we exit before the actual program arrives to this point, so the routine terminates. But I guess we could remove this, and that would do as well. So if we remove that, we also propagate the signal at the end of the context, and you can see that it gets propagated and the context gets cancelled. It wasn't easy to see in the beginning here, because the program was being shut down. But this is how easy it is to use the context with timeout and with the cancel function. And obviously, if you just needed the cancel function, you could have used the context cancel. You could have used. So let's go doc context with cancel. And this is basically exactly the same thing as the context with timeout, but in this case it will just return a context that never expires, and it only expires whenever the cancel function is called. So this is a sub problem of what we have seen, and what we have seen has been we've been able to solve the problem we had just by using one type of context, which is godoc context with timeout. So the context with timeout acts effectively both as a timeout and as with cancel, because you still have the cancel function as well here, which you can call, and it will propagate the cancellation of the context. So it's pretty powerful, and you can do a lot of things with it. Thanks for watching, and I hope you liked the video, and let's catch up at the next one. Thank you.